morning, guys. You ready to have some fun? Putting it all together, what we did this week, and have a little fun with it. Maybe, that's the hope. Maybe we have a little fun this morning. Put together what we've been working on all week long. Show how this would be used. Well, not really, but kind of, sort of. Hey, good morning, Eve. It is bright and early morning on this Thursday morning. We made it through a week, almost. We're almost done. Hey, Bo. We're here this morning, ready to go, raring to go. Priscilla, Courtney, Jasmine, way to go, guys, way to be here. Settling in. We kind of got a routine, sort of, kind of, anyway, now that we've done this for 2 weeks. Starting to get it. Starting to figure out how this all works. This is going to be a fun little application task. It is Thursday. We made it. We made it to Thursday. Don't want to wish my life away, but man, Thursdays are great. Hey, Kelsey. Good morning, good morning, good morning. Now we get to have a little fun with it. Morning, Aunt Kara. I know. It's been work all week, and now it's going to be a little bit of fun. Maybe. Kind of, sort of, anyway. 2 weeks already. I think it's only like 4 weeks left. Just like 4 weeks left. We can do this for 4 more times. And I'll just get better. I'll make it better and better each week. I promise. I promise. I'll make it better and better each week. Try to anyway. I'm sorry I deserted y'all yesterday. We had a small medical emergency at my house. And you know, nowadays you can't go to the hospital, so it's fine though. It's fine. Everybody's okay. We made it through. Sometimes I think I should get like an honorary nursing degree. Fun for you too, maybe. Maybe. Maybe you see that stats can be fun, sort of. If you liked the application task last week, if that was fun, which a bunch of you guys included your kids, that was fun. You got to, you had them draw last week or whatever. This week you can have them spin. I see an LH, but I don't know who LH is. So I can't give you bonus points for being here if I don't know who it is. So let me know somehow or another. I know, right, Aunt Kara? We did okay. We ended up calling a pharmacist to get it taken care of. It's all right. It's all right. And then eventually the doctor did. We used my chart, but the doctor wasn't getting back to us. I mean, I know they're busy. They can't just do it immediately. But we kind of needed somebody. And so I called the pharmacist and they gave me good advice. And then later in the day, the doctor just confirmed what the pharmacist said. So we were able to get it. I love my chart. But hey, Zoe, how's it going? It's gonna be fun. It really is. Oh, hey, Lucas. Hey, Lucas. Good, 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 good. Y'all are doing great. Oh, that's good to know. I am glad to know that, Aunt Kara. I am glad to know that, because that's, right now I'm like, what? I'm having bad dreams about not being able to go to the hospital. It's a weird worry, but I think it's because we're at the doctor's, I swear, for some condition or another, every other day. Now we're not making those runs. So, it'll be all right. We'll make it through. I think that's the part of this that a lot of people aren't realizing. They're like, well, I'll never get the virus. It'll be fine. But they don't realize that they could be in a car accident and be affected by the fact that the hospitals are full, or your appendix could burst and then the hospital's full. So this physical distancing, y'all keep doing it. Keep doing it, keep doing it, so this will all go away eventually sometime or another. No visitor, oh my gosh. I just think there's a little kid in town who just recently got a heart transplant, and I'm thinking about him and his parents. His mom couldn't be there with him when he got the heart transplant. I just, situations like that would be really, really tough. I know that's hard. Okay, so let's do this task. It really is going to be a little bit fun today. Maybe, kind of, sort of. Maybe not as stressful as the last 2 days we've been with the homeworks. And I'm going to, next week is going to be better. And to help with the binomial and the hypergeometric homeworks, if there are some on there that you're struggling with, here's what I did. Yesterday I created solutions for those homeworks, and I post them on D2L under Content tab. So if there's a specific one that you're having trouble with, like Lucas, I was doing a horrible job of explaining things to you yesterday for number 10. I mean, it was awful. So, but I put the solutions, I wrote it all down, and I got it all done, and then I put it down, I put the solutions on D2L under the Content tab. So if you look under Content and Week 2 Solutions, it'll help you to see, how I worked through it. So y'all can work through it and then check your work with mine, or if you're like, I don't know how to even start this, go look at my solutions and see if that helps too. Yeah, Lucas, that's exactly right. People like your grandma, those are the people that are going to be affected by this. So, I did. Well, no, I didn't do it with hypergeometric for number 10. And I did not. I was trying to do it with number 10 with Lucas, and it's like, forget it. So when I did my own solution, I didn't, because it's not 2 choices. So you can't really use hypergeometric. So the way we did it, though, was a better way to do it. That's really how it should be done. And if you do it enough that way, then you begin to see the patterns so that you can use the combinations to help. But really, just brute force with the classical is the way to go until you begin to see those patterns. By the way, math is all about patterns, and being able to see the patterns is super important in math. So if you're planning on doing any more math, that's like the biggest part. That's really what makes a great mathematician is being able to see those patterns in the math. So I know, Lucas. I'm sorry, I think partly I just wasn't all there. I was not there. Yes, Mr. Simpson, you are way late. We've already had we saved the world. That's what we've done. Okay, so today you're going to make a spinner for me. That's what you're going to do in this application task, is you're going to create yourself a spinner. So I went around the house and looked for things that I could find that would make good spinners. Like, for instance, just my bicycle wheel. I could make that into a spinner. There's a spinner that if you've got a bike lying around, you could use that as your spinner. Or, set that aside. My poor bike's not getting a lot of use here lately. Or maybe you have a fan. You could take the cover off and just spin the fan. Or, here's a lampshade. I've got this lamp with a lampshade that spins around. I can make a spinner out of my lampshade. Or you could create a spinner, get some cardboard, cut out a circle, this is just a thumbtack and a paper clip. I used a paper clip, or you could maybe use string and a needle or something, but you could take a paper clip and just punch that through, and then you have a spinner. Well, it's hard to do up and down. It works this way. So I'm going to use my Dr. Pepper clock. So I have this Dr. Pepper clock that doesn't work anymore, and I can spin this spinner. The second hand makes a great spinner on it. Okay, so that's first thing, is you have to find yourself or create yourself a spinner. Then what you're going to do is you're going to label. So in my spinner, I'm going to take it and I'm going to divide it into 3/4 of it is going to be success, and 1/4 of it is going to be failure. Or is it the other way around? Y'all look at the task and see which it is. Is it 1/4 win and 3/4 fail, or the other way around? So we've got our little spinner. Either way, it's 3/4 one and 1/4 the other. Y'all look it up and tell me which is supposed to be success and which is supposed to be fail. I've forgotten. I looked it up and now I've already forgotten it. So here's my, 1/4 and 3/4, and then 1/4 win. Okay, so 1/4 win. My 1/4 win is going to be drink Dr. Pepper. And my 3/4 fail is going to be don't drink Dr. Pepper. But, whatever you want to make your success and your failure. You can make it, do my stats homework, don't do my stats homework, and whatever. Ride my bike, don't ride my bike. Stay away from people, don't stay away from people. Whatever. You come up with your own. Then, so now I've got 3/4 failure and 1/4 success. So you can see that we've got that binomial situation going on where we've got two outcomes, success and failure. And then we have the probability is going to stay the same because every time I'm going to have 1/4 success and 3/4 for failure. Then what we're going to do is we're going to spin that spinner 5 times. So we have that fixed number of trials. So your early bird this morning, to warm up our brains, we just want to know what's the possible number of outcomes that we can have. In other words, what's the possible number of wins that we could have? So when we're creating our probability distribution, and this is going to be important next week too when we do expected value, we'll have to create a probability distribution for each one of them. And so you have to be able to come up with what are your outcomes, how many possible outcomes are there. And here, the possible number of successes, we call this our random variable. This is the thing that varies, is how many successes we get. That's the random variable. So I label that as X. So how many different possible outcomes can I get? Y'all help me out. How many of those X's am I going to be able to get? How many successes? If I spin this thing 5 times, how many successes could I get? And I'm going to spin it 5 times. 1, 2, 3, 4, 5. How many successes can I get? Help me out. Wait, I don't see any answers yet. Maybe I'm just below. I'm behind a little bit. Y'all are going to answer that, and then while you're answering that, I'm going to also tell you about our haiku this morning. Daring to march on when all seems impossible. Nothing's more courageous. So y'all, I know this is tough. This seems really hard. But you can do it. Keep marching on. We can make it. You've got the courage in you. I know you do. All right, yay, there we go. Those are the possible outcomes. So I could get 0 number of successes. I could get 1 success. I could get 2 successes. I could get 3, 4, or 5. So those are my possible outcomes. Now, what we're going to do is we're going to come up with the probability for each one of those. So before I actually do the experiment, we're going to come up with, in theory, how many should I get? So in theory, what's the probability that I should get 0 of these? So first, this is the theoretical, or you could call it the classical, in theory, probability distribution. So in theory, I want to get 0 successes. So this is what we did this whole week. This is what we've been talking about. We've got a binomial situation, success and failure. Probability stays the same. And I want to know how, what's the probability I get 0 of those successes. So what's the probability that I get 0 successes? So how am I going to go about doing this? Oh, maybe. Mr. Simpson, I gave that bonus out about Pascal's triangle. Nobody's turned it in yet. So I'm going to use the Horde formula. I'm going to torture them until they do a little bit of work on their own with the Pascal's triangle. That was their bonus, was they're supposed to find out how to use the Pascal's triangle. Oh, I like it, Bo. Let's use that binomial formula. So here on the first one, well, let's talk about what my variables are going to be. My n, my x, my p, and my q. My n, my x, my p, and my q. So the number of trials, what's my n going to be? What's my n going to be? Let's see, the number of trials, I'm going to spin it 5 times. My p, my probability for success, well, it's 1/4 of the spinner. 1/4 of the spinner. Good, guys. 1/4 of the spinner is success. That means my Q is 3/4. So 1/4 is success and 3/4 is not success. And then X is going to change each time. See, it varies. So we're going to go through and do this for each one of them. The probability of 0 first. So first my x is going to be 0. And now, good, 25%, perfect. Now I'm just going to fill that in. 5, choose 0. That's going to tell me how many different ways I could do it. I could win. Oh no, if I'm going to get 0 wins, I have to lose and lose and lose and lose and lose. It's the only way to do it. So since that's the only way, this should equal to 1. And if you look at the Pascal's triangle, on the ends, it has those 1s. So it gives you a 1 there. And you figure out that after you look at that Pascal's triangle, every time you have a 0, it gives you a 1. Then I'm going to do 1/4, 0 times. We're not going to have any successes, so I don't need that 1/4 as my thing. I'm doing lose and lose and lose and lose and lose. And that is equal to, when I raise any non-zero number to the 0 power, it's equal to 1. 3/4 then gets raised to the rest of them. Because I'm going to do 3/4. It's lose and lose and lose and lose and lose. So 3/4 times 3/4 times 3/4 times 3/4 times 3/4. So 9 times 9 is 81 times 3, 81 times 3, and on bottom I've got 256 times 4, because this is 16 times 16 times 4. So to get the probability of 0, you'll help me a little bit. That's 243 over I'm going to do it in a different color so I can see it. How about red? 243 over, well, that's 24, carry 2, 22, carry 2, 8, 9, 10. That's what I got. You got your little calculators with you to help you? Oh, yeah, thanks. 243 times, over 1,024. So my denominator here, if I did this experiment 1,024 times, if I did it 1,024 times, I would expect 243 of them to get 0, whatever those are, successes. Somebody on your little calculator right now do this and find out what this probability is. I know it's going to be close, if what percent, what the percent is. So, I know it's going to be close to, I need to get down to 100. Well, to get down to 100, I'm dividing this about by 10. So if I divide that about by 10, I should get about 24-ish. So I bet on your calculator you do 243 divided by 1,024, you're going to get about 24%, yeah, roughly 25%, somewhere right in there. Because all we're doing is getting down to 100, we just divide that by 10. Okay, so there it is for 1. For 0, let's do 1. So now the only thing that's going to change is 1, because we're still doing 5 trials, we're still doing 25%. We're still got 3/4. So the only thing that changes here, let me just show you. When I do this, the only thing that changed is I took away the x, and then these exponents I took away. So here, I'm going to put a 1, because now my x has changed to 1. I'm now looking at 1, 1, 1. So then, if I get 1 win, or 1 success, one time I drink a Dr. Pepper, how many am I not drinking Dr. Peppers? So if I'm not drinking Dr. Peppers, it's at 4. Wow, look at that. We were really close with the estimate, that 23.73%. That's really close to 24. So you see, calculators are great, but you can begin to do things in your head if you just know that the way you're getting down to get the percent is just you're taking it and dividing it down to 100. All right, we've set it up. Now it's just a matter of doing the math. I'll let you figure out the combination, or if you've looked at that Pascal's triangle now, you know that every time I choose 1, if I look at the first entry on my Pascal's triangle, it's always going to be that number, whatever the top number is. So that's just going to be 5. Then I've got 1/4 one time, and then 4 failures. So 1 success with 4 failures. So 9 times 9 is 81 times 5. And on bottom, we should have that same 16 times 16, which is 256 times 4, which I now know is 1,024, because we just learned it. So that's 405 over 1,024. 4,005. Now you just take and divide that by 10-ish to get an estimation. So divide that by 10 to get down to 100. I'm just approximating. Divide that by 10 and you got about 40%. Notice this one is a little bit more, this one's more probable than that. It's more probable that we get 1 success than we get 0 successes. That's more probable. Yeah, Adam's been using that Pascal's triangle over and over and over again. So we know there's got to be something to it, right? And Mr. Simpson swears by it. And after you do it for a little bit, it is true that you begin to recognize some of the patterns in it. Oh, look how close that is, 39.55. So 39 and 55 hundredths%. That is really close. Our estimation is super close. All right, now I'm going to choose 2. And I'll let you do here's the 2. So if this one is 2, I have 2 successes this time. I'm doing 2 successes. Then how many failures are there? If that's 2 successes, then how many am I not getting, or how many non-successes, how many failures do I end up with? Well, it needs to be this plus that needs to add to the 5. So 2 plus 3 makes that 5. So I have 2 wins and 3 losses, or 2 successes and 3 failures, or 2 I get to drink the Dr. Pepper and 3 I don't. Good, 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 good. Perfect, Lucas. Y'all got this. Way to be, way to be. Now, I'll let you do the combination, or you can look at the Pascal's triangle and see the 5th row and the 2nd entry and see what that is. I happen to know, because I've done the Pascal's triangle so much, it's just equal to 10. Or maybe it's just because I've done the formula so much. I'm going to let you go through that and look at it though. Here, I'm doing 1/4 times 1/4. And there, I'm doing 3/4, 3/4, 3/4. So 2 successes, 3 failures. We say, well, this, we couldn't reduce, right? So I can make this to 5 and that to 2. Or I could have left it with the 1024. Maybe it's better just to multiply across to keep my denominators the same. Normally we simplify it. If I don't simplify it, it ends up being 9 times 3 is 27, 2,700. No, 270. No. 9 times 3 is 27. Times 10 would be 270. That seems weird. That doesn't seem right. 9 times 3, maybe it is. Okay, yeah, it's cool. It's cool. Okay, okay. I'm back with it again. So, but if we simplify it, then we're doing 9 times 15, or 27 times 5 maybe is easier. And then you've got 16 times 16 is 256 times 2. So simplified, it would be 35, carry 3, 10, 11, 12, 13, 12, carry 1, 10, 11, carry 1, 4, 5. Let's see if that makes sense. If I divide this one by 2 and I divide that one by 2, yeah, I'd get this. Either way, this is probably, this is a sexier form, right? It's prettier, but I may want this just to check myself at the end. Good, y'all have already figured this out. If I simplify that down, divided by 10, it's about 27%. And sure enough, that's exactly what you got. About 27%. So this is, this is the simplified form. I could have written it 135 over 512. This, and that are about the same. These two for sure are the same. Okay, now I've done 2. Now I'm going to do 3. So I'm just changing my x value. Changing my x value. 3. this 3 goes there, so how many failures am I going to have? If I've got 3 successes, then how many failures do I have? Then remember, these two have to add up to the total number of trials. If I've got 3 successes, that means I have 2 failures. Good job, guys. All right, again, I'll let you look at the Pascal's triangle, the 5th row and the 3rd entry. Or you can use your combination formula and get 10 is true. It is 2, and it's also 2 factorial, because 2 factorial is 2 times 1. Good morning, Amanda. So this 10 is 1/4 times 1/4 times 1/4, because I have 3 successes and then 2 failures. I agree. If you'll figure out the Pascal's triangle, it really will help. And I did that on Monday, I think. I gave you that bonus opportunity. So if you missed out on that bonus opportunity, if you don't remember what it is, go back and look at that live stream. I've posted all the live streams under the content tab also in D2L. So you can go back to Monday's was Binomial. Go back to Monday's live stream at the end and look to see what that bonus opportunity was. Because I set it up for you, so maybe you can figure it out. Yeah. Oh, you were just excited to say 2. You weren't doing 2 factorial. Okay, so here again, if I could simplify that 10. By the way, 5 choose 2 and 5 choose 3 were both 10. Interesting, huh? There were 10 ways to get 2 successes, and there's 10 ways to get 3 successes. Now, I'm going to take and multiply. If I simplify, then it becomes 9 times 5, which is 45, over 256 times 2 was 512. If I don't simplify it, then it's 90 over 1024. But really, that sexier form is the simplified form. Good job, y'all are already doing it. So 100, you're dividing it by 10-ish, so about 9%. And sure enough, y'all tell me it's 8.7, 8.8%. Sure, right there at 9%. All right, so we've almost got this probability distribution made. We just need 2 more, the 4 and the 5. So now I'm going to do the 4. And then we can start having some fun. Once we've figured out what we expect to happen, then we can look at the empirical, see what really happens on our experiment. So here's the 4. Fill in those 4s. This becomes my x. If I get 4 successes, then how many failures do I have? 4 successes, and then I end up with, well, these 2 need to add up to be that. So 1 success. Failure, 1 failure, 1 failure. Look on that Pascal's triangle in the 5th row, the 4th entry. Or if you've done this enough, you begin to see that when these 2 are one apart, it's always going to be that top number. Yeah, always is 1 less. When it's 1 less, it's always this one. And then you've got 1/4 times 1/4 times 1/4 times 1/4. And here times 3/4. No reduction this time, no simplification. That doesn't go into there. So I'm just multiplying straight across. We know now that 4 to the 5th power is 1024. Y'all just know that now, right? Getting good at party tricks. And then 15, because that's what y'all do at parties, right? Is you give out some math question and you see who can answer it real fast. Because that's what our parties look like. So 15 over 1024. Why do you think I had a marker board in my house to begin with? It's for the parties. Okay, then last but not least. Oh, and this is about, divide that by 10. Ooh, that chance is not very good. We're down to 1.5, about 1.5%. So we shouldn't get 4 successes very often. That shouldn't happen very often. All right, last but not least, we're doing the 5 times. 5. We're going to see if we get 5 successes. How often will we get 5 successes? Well, if we're getting 5 successes, we're not getting any failures. We're only getting success and success and success and success and success. And think about that. It's success and success and success and success and success. That, I agree, Lucas. No parties being had right now. Unless you do them virtually. We could have a virtual party. We could get on Discord and party. I like it, because this is just equal to 1. This is 1/4 times 1/4 times 1/4 times 1/4 times 1/4, and that's just equal to 1. So good, 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 good. Y'all beat me to it. You did it. 1 over 1,024. Or talk about a teeny tiny percent. That's so small. You know, if I've got 100 here, divided by 10, I'm just at 0.1%. 0.1%. That's right. Turn up on Discord. Do our homework together. Yeah, look what Adam said, 0.09. So yeah, it's really close to that 0.1%. So that barely happens. We're not going to get 5 successes very often. Okay, so this is the first thing you're going to do tonight, or for your task, is you're going to create the theoretical or classical distribution. Then, once you've done that, now we get to play with it and do our empirical. We're going to see if in the real world, when we do this experiment, if those are the same probabilities that we get. You know that's your highlight of your week, is to get on Discord and do homework with us. That's the highlight. It is the party. Okay, so here's my spinner, ready to go. And now what I'm going to do is I'm just going to empirically try this. I'm going to actually do this experiment, and we're going to see if our probability matches that. So I think in the instructions it tells you to do the experiment 6 times. So I'm going to do it 6 times. So, you know, my first time, let's document what we get. So here's my documentation. I'm going to do it 6 times. There's a failure. I'll write that down. Fail. I didn't get to drink my Dr. Pepper. Fail. Success. Fail. Fail. So there, I did the experiment once. Now, I'm going to do it a second time. There's my experiment. I spun the spinner 5 times. And notice how many successes did I get there? I just got 1. So I got 1 success there. Okay, so maybe I write that down somewhere. This is 1 success. I don't know. Maybe I save it for later, whichever. Okay, now I'm going to do the experiment a second time. I'm going to do it again. I got a success. I got a failure. I got a failure. The spinner could spin a little better. I got a failure. I got a failure. Only got 1 success again. Yes, that is a party foul. I even marked on the floor. Darn it. I remember when we got our house in Nemo, Texas, we found Nemo back before Nemo was cool. And we had a party like when we first got the house, we got a party and somebody spilt something on the carpet. That stain was there from then on. It reminded me of that party. Maybe it would do better if I laid it flat. Third time. Okay, notice again, I got one success. Yours will probably do, you guys can all lay it flat. I'm trying to show y'all, so that helps. And I couldn't use this one because if I show you with it, it always ends up down on the bottom. So that's the reason I'm using the clock. All right, so I'm going to show you again. Here we go. That's a failure. That's a failure. 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 That time I didn't get any successes. So 0 success. Fourth time. By the way, you got to find a way to video yourself doing this. You guys got phones? Use your phone to video yourself. You know, video yourself. Use a cereal box or something to prop up your phone. Take a video of yourself doing the trial, and then put it somewhere and send it to me. Tag me on social media. Upload it to YouTube. Something. Let me know. Show me that you're doing it. Or if you had your kids spinning it, that works too. Get them involved. That is a failure. So I'm doing it the fourth time. Failure. 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 Come on, I need a success. Oh, there's a success. One success. All right, I've done this four times. Fifth time. Oh, that'll work too. Use that cereal box for your spinner. Fail. So now I'm doing it the fifth time. I want to see the spinners though. Y'all show me what you used as your spinners. So in your video, you know, you're spinning the spinner. I should be able to see your spinner somehow or another. Failure. Failure. So again, I had 0 successes. Last time. Fail. I'll count that. Oops. Success. I'm going to count it as a success anyway. Fail. 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 Again, I only got one success. Okay, so I did it 6 times. That's what you're going to do. You're going to do your experiments 6 times. Remember, the more experiments that we do, the more our probability should be like the theoretical probability. That's that law of large numbers that says the more that we do, the closer it should get to this theoretical probability. So this is the empirical probability. Empirically, what did I get? Well, here, my x's, I still could have gotten 0, 1, 2, 3, 4, or 5 successes each time. But how many times did I get 0 successes? Well, I got 1, 2. So the frequency here, I got 2 with 0 successes. So this is the number of successes. This is the frequency of those successes. So 0 successes, I got it twice. 1 success, 1, 2, 3, 4 of those. 2 successes, I didn't get it all. 3 successes, I didn't get it all. 4 successes, I didn't get it all. And 5 successes, I didn't get it all. This is the frequency. This is called a frequency distribution. So that's one of the parts of your task. You're supposed to turn in your data. You're supposed to turn in a frequency distribution. So I just did the frequency distribution. Now let's look at the probability, empirical probability distribution. So I'm going to get rid of my data so we can see it. So we can make it. So now for the empirical probability distribution. The probability. So here it is frequency, here it is empirical probability. And this just reminds me of that relative frequency that we did at the beginning of the year, where we take our frequency and just put it over the number of times we did the experiment. So just relative to what? Well, it's 2 out of the 6 times that we did it. So still my random variable is the same. I could have gotten 0, 1, 2, 3, 4, 5 successes. But now I'm just talking about the probability that I actually got those successes. Well, empirically, I got 2 out of the 6. 2 out of the 6, or 1/3 of the time, I got a 0. So my percentage was 33% that I got 0. Now look, 24%, 33%, that's not too far off. Okay. For me, 4 out of my 6 times, I got, or 2/3 of the time, I got, that's about 66%. So empirically, I got it 66% of the time. That's a little high. That was a little bit higher than maybe it should have been. Maybe my spinner's a little off. We could do, later we'll find out when we talk about, if we did the standard deviation of it, and we found out, we could start to find out, how improbable is it that I get that? What range with Chevychevs I could begin to see? Does that fit in that? Is that normal? For me, I didn't get any 2 successes, so mine was 0. The probability that I got 2 was 0. The probability I got 3 was 0 out of 6, so it was 0. The probability I got 4 was 0. The probability I got 5 was 0. They didn't happen. So empirically, this was the actual data. And it was less likely that those things happened. So maybe that's like normal for me not to. If I had kept doing it over and over and over and over again, then it would have been closer to this in theory. I just did it 6 times. That's a teeny sample. That's so small. If I wanted it to be in theory, if I wanted it to get closer and closer to this, I would need to do a bigger amount of it. That's that law of large numbers. The more you do it, the closer it gets. But really, if you look at it, it kind of makes sense that I got 1. That had the highest, and mine did too, while the rest of them were smaller. So even in my small sample, it came close to it. All right, so, and then what you're going to do is you're going to turn all those pieces in. Your theoretical, your data, your frequency distribution, your empirical probability distribution, a video of you doing it, or at least a picture of you with your spinner, something. If you, for some reason, can't get the video, then at least send me a picture with your spinner. All right. Anything else we need to cover? Wow, that was fast today. Is that everything? That's it? Your job, yeah. Put it on social media, the picture or the movie. Tag us so you can get bonus points. It has to be tagged in such a way I can find it. So make sure I can see it. And Rimson says tag him at Push That Rock. Especially on Instagram. He does Instagram and Twitter. So if you're on Snapchat, you just do me. I mean Simpson Math, Simpson_math. If you do, what else is there? That's about it. Facebook. Facebook's hard. Yeah, that was fun. So tag us on it. Snapchat's for losers. Instagram it, be one of those. Okay, yeah, I like it. Put some video on there and tag us. I love it. Okay, your job is to get all your homework done, get this task done, get it uploaded to Dropbox so I can grade it. Some of you have already done that, great job, and then I've been able to give you feedback, and some of you already have your grades done. So as you finish it, upload it to Dropbox. If it's in before tonight, then I'll get it graded and get it back to you. But after 10 o'clock tonight, then tomorrow, I can't guarantee that you'll get any feedback. So make sure it's, oh, that's right, and the little assessment that has, oh, let me talk about that, Bo. I'm glad you brought that up. Because on the assessment, you now have to figure out which you're going to use. Are you going to use hypergeometric or are you using binomial? How do we know if it's binomial or hypergeometric? Like which one, how do we know which is which? How do I know when to use hypergeometric and when to use binomial? How do you know? What is the clue going to be to let you know, oh yeah, I'm going to use hypergeometric for this one, or I'm going to use binomial for this one? What's the difference between the two? What's the difference between the two? Do you know? Do you remember? That's right, success or failure is getting your homework in or not. Both of them have success or failure, right? Both of them have a set number of experiments, right? So what is the third thing that makes it different? Because both of them have that. Good, Eve. In a binomial, the probability always stays the same. So if I give you something like 1/4 of the time, every time, then you know that's binomial. If I say that, 2% of the people have or whatever, it's a 2% chance that you get laid off or something, well, that 2% chance remains the same. That's binomial. But hypergeometric, it changes, so you think without replacement. Good, that's exactly right. Hypergeometric without replacement, binomial with replacement. Hypergeometric, the probability changes. Binomial, it doesn't change, it stays the same. So that's how you know which is which. That's what you do with that. Good job, guys. All right, let's have some fun. I'll be on Discord today. Hopefully I will not have any medical emergencies I have to run away for. So I'll be right there working. And as you need me, just pop on. And then also remember the solutions for binomial and hypergeometric are under the content tab, so you can kind of look at those too to help you out. All right, y'all have a great weekend. Please turn everything in. I'm desperate for you guys to get it done. I really want y'all to pass. All A's this semester, all A's. And I'll keep throwing points at you so you can do them. Go back and learn about that Pascal's triangle too. Get those bonus points. All right, see y'all on Monday.